All right, here we go. A quick video on chapter 12.3, equations of lines for vectors. Previous video, we had seen if they're skew or they're parallel. Remember, if they're parallel, they will share a scalar multiple. If they are skew, then two of the lines can be satisfied, or two of the components in x and y, but the third component will not be satisfied. So now we'll find out if two lines L1 and L2 intersect. How do we show that? So let's see. We have L1. It says, example 3, show that L1 intersects with L2. Here are the parametric equations for each. L1 has an x of 1 plus 2t, y equals 3 minus 4t, z is negative 2 plus 4t. For L2, we have x equals 4 plus 3p, y equals 4 plus p, and z is equal to negative 4 minus 2p. Again, what we want to do is set these up and compare them similar to a system of equations. So I just chose the x and the y components, and I line them up, and I notice that nothing cancels right away. However, if I were to multiply this set here by a negative 2, or by a 2, excuse me, then what I would end up getting if I distribute this 2 is come down here, we get 2 plus 4t is equal to 8 plus 6p. I bring this equation down here, and it's 3 minus 4t equals 4 plus p. So again, all I did was try and find a multiple where I could eliminate one of the variables, either p or t. It doesn't matter. In this case, I chose t because it was an easy multiple. And so once you do this, you'll notice that these 4 t's go away, and we're left with 2 plus 3 is 5 equals 8 plus 4 is 12 plus 6 plus 1p is 7p. If you subtract 12 from both sides, you'll end up with p is equal to negative 1. All right, so that's the first step, to compare those two. Now what we want to do is we want to start looking to find out what the t value is. So we substitute, over a little bit, we substitute the value of p that we found here into one of the equations, and we solve for t. So 1 plus 2t equals 4 plus 3 times negative 1 as my new p value. And I just took the original equation that we had there and substituted in negative 1. We get 1 plus 2t is equal to 4 minus 3 now. And you'll notice that if that gives me a positive 1. If I subtract 1 from both sides, divide by 2, I still get t equals 0. So in this case, our t value is 0. Now what we're going to do is we're going to substitute that into the third equation to see if it satisfies the third equation. So we have a value of p of negative 1, we found there, and we also have a t value of 0. So I'm going to plug those into the z equation. So this was the z equation. And we get negative 2 plus 4 times 0. Does that, in fact, equal negative 4 minus 2 times negative 1? And in fact, I urge you to pause the video, do that algebra really quick, and see if you come out with a correct an assumption that you can make about whether they're equal or not. All right, well, welcome back. You do notice that this is negative 2 on the left, and yes, in fact, it does equal negative 2 to the right. So those values do, in fact, satisfy the z equation. And now, lower this a little bit. Now what we need to do is find the point of intersection, and when we do that, we can either use t equals 0 or p of -1. We substitute that back in to any of the equations. Now I found that going back to the original equation of L1 and using the t values, meaning I'm going to zero out that, I can zero out -4, and I can zero out 4 times t also. So if I plug zeros in for all those t's, because that's the value we found for t, I will end up with 1, 3, -2 as the point of intersection. And in fact, when you look at it, that in fact is the point of intersection, 1, 3, -2. All right, so hopefully that helps. Points of intersection and two lines that intersect in Vectorville. Hope you have a great day. Thanks a lot. Appreciate it. Talk to you soon.